Okay, so we're going to be measuring mass using a triple beam balance. The first thing you have to do when you're doing and using a triple beam balance is to make sure that the balance is ready to go before you even begin. So it needs to be balanced before you put an object on there, and you do that using the little knob on the end, right down there. Okay, so let's go ahead and put the first object on. We're going to be measuring the mass of this piece of mineral. So go ahead and put that on the pan. And you want to see if the big one is too big, and it's too big. So we're going to move that one back and we'll go to the next one, which is in the tens. And you wait to see when it goes all the way down. So we're going to back that up to 20 and start moving the ones forward until this edge begins to balance. This one right here. If it goes too far, you have to back up the number and then go to the scale in front of it. We're measuring density today of different objects. And to find the density, we need both the mass and the volume of each of the objects. And then we use the mass and the volume to calculate the density. And so we made some predictions today about which object we felt would be the most dense out of the ones that we're testing and calculating. And one of the skills we need is to use the triple beam balance. Getting closer. Sometimes this takes a little bit of time. And once we think we have it, then we add the three columns together. So what is our... That's pretty close. I think that'll do it. Bingo. So what are we going to do? We're going to add that column and this one. And what is our final?
25.85.
There we go. And you can look at the scale and see that's a really nice way of practicing measurement too. And then we're writing that down in our data charts. It's always best when you're finished with a balance to make it go back all the way to 0 again. And then the next person will go. And once we have all of our volumes and all of our masses, then we're going to use the calculation, which is density equals mass divided by volume. You might be wondering about our data charts and where we got this from. We made our own. I'm a huge, huge fan of doing your own data chart because when a scientist is in the lab, nobody's making handouts. Nobody's making those pretty printables. They have to go into the lab and they have to make their own and design their own. And it's a great way for kids to learn how to organize their own information. So we have 3 levels working together today. I have an 11th grader, a 9th grader, and a 6th grader all working on this today. So what we're going to do now is measure the volume of this irregular object. If we have a regular geometrical shape, then we can use a mathematical formula to find the volume. But if you don't have that, then what you want to do is find the volume by displacement of water. So what did you fill up your graduated cylinder to?
200 milliliters.
It's okay, so the level of the water is at 200 milliliters. Go ahead and drop your object in. Notice how we flip the graduated cylinder on its side a little bit so we don't slam the object into the bottom of the graduated cylinder. And what do you have for the final volume?
220 milliliters.
Okay, 220. So this is actually a 500 milliliter graduated cylinder. It's large enough to get bigger objects in. And how do you know what the volume is? What are you going to do? It started at 200 milliliters and it went up to 220 milliliters. So what's the final volume?
We take the 200 and take this 220 and subtract 200 and 220.
Yep.
And you get 20, which is 20
And what's that unit on that?
milliliters.
Milliliters. Very good. Thank you.